Welcome to this episode on fasting. In this session, I am going to unpack the spiritual roots of this ancient practice, explain some of the physiological mechanisms involved, and enumerate some of the incredible benefits that can be conferred from imposing just a little scarcity inside our world of endless abundance. Fasting is old, and while Christianity, Islam, and Buddhism don't always see eye to eye in terms of religious and political beliefs, their respective prophets, Jesus, Muhammad, and Buddha, were all fasters. All three of these robed mystics embarked on spiritual walkabouts, solitary journeys of contemplation, discovery, and self-inquiry. Jesus to the desert, Muhammad to the cave, Buddha through the mountains of Nepal. And as part of these spiritual inquests, they all temporarily suspended their consumption of food. As Jesus confronted the devil, he was tempted neither by Satan's offerings or, evidently, by lunch. This 40-day period of asceticism became known as Lent. Muhammad intermittent fasted on the regular and recommended time-restricted eatings to all Muslims on the 13th, 14th, and 15th of every month. These days of the lunar calendar are known as the white days, due to the full moon. In fact, in Islam, fasting, or Psalm, is a requirement for attaining God consciousness and one of the 5 pillars of the entire faith. Further, it is mythologized that Muhammad received the Quran during the 9th month of the Muslim calendar from the angel Jibril in a fasted state. The 9th month of the Islamic calendar is called Ramadan, and one of the primary observances is fasting. Lastly, it is also said that the Buddha existed for a time prior to his Bodhi tree revelation on a singular daily grain of rice. Now, many religious traditions are built upon the notion that transcendence rests upon lifting ourselves out of the ephemeral body and into the eternal spiritual realm. We sublimate the appetite and our other carnal desires to grasp the infinite and find enlightenment. Okay. You don't need to be a follower of ancient scrolls to observe how cycles of fasting and eating are inherent to life's foundational fabric. The oppositional states of abundance and scarcity that foster balance between physiological growth and repair are part of nature's course. Over hundreds of thousands of years, humans have evolved adaptively in relationship to these environmental prerogatives. For example, humans have developed genetic pathways that signal the body to store fat in anticipation of the impending winter, which served as a naturally imposed sort of fast. So let me unpack that for a moment. So long before we were stalking the Serengeti of Facebook, Homo sapiens foraged the savanna and forests for food. On a splendid fall afternoon in 10,327 BC, Fej Onsark, my ancestor hunter-gatherer from East Africa, stumbled to his great delight over a marvelous copse of barberry fig trees. The trees were so laden with ripe, reddish teardrop figs that they appeared to be crying. Fej enthusiastically harvested all the figs, stuffing his satchel full to where its skin stretched taut, and he proudly brought them back to his village, where the tribe gorged exuberantly on the figs until all that was left was a small mountain of stems and leaves in the center of their dining circle. Now, the next day, Fej returned to the grove with his men's group, who ransacked the remaining trees. They hauled a great bounty of figs back to the tribe, who devoured them again with reckless abandon. Now, after a week of great abundance, Fedge found that his linen loincloth was a little tighter around the midsection. Oh, he didn't judge himself. He wasn't on Instagram. His little paunch would come in handy soon enough as the scarcity of the upcoming winter loomed. Back before convenience stores in the fall, nature wanted us to be fat. Now, food contains macro and micronutrients that the body metabolizes for its myriad functions. Food is also a messenger. It contains information. So certain constituents of food give signals to cells to act in a certain way. Let's look at the fig. Now, a medium-sized fig contains approximately 8 grams of sugar, 60% of which is glucose, and the balance is fructose. Now, during digestion, these sugar carbohydrates are absorbed up into the bloodstream. Now, glucose triggers insulin from the pancreas. Kind of like my daughters use Uber. Glucose hitches a ride from its insulin cabbie and gets taxied off to the cells for the process of energy production. Now, fructose doesn't have the insulin app on their iPhone, and instead it gets directly metabolized by the liver. The byproduct of fructose is purines, which in turn produce uric acid. Now, uric acid signals cells to become resistant to insulin. In other words, less glucose is able to enter the cell for the production of ATP, and instead it remains in the bloodstream. Now, when glucose loiters in the blood for too long, it has numerous fates. It can get stored as glycogen in the liver as warehoused energy for use on a rainy day. It can also form inflammatory glycoproteins. These are called advanced glycation end products by fusing with proteins like hemoglobin. And it can be stored as triglycerides in adipocytes, commonly known as fat cells. Now, this mechanism resulting in fat storage represents the brilliance of nature's intelligence. Across millennia and millennia, the body developed the adaptive mechanism of making fed just a little fat during the abundant harvest because nature knew that the yang of the bright autumn yield would be dimmed by the yin of winter's fallow. Fed would require fat storage because food supplies would naturally dwindle. Copious glucose would dry up, and in order to produce the energy required for life, the body would need to break down triglycerides into free fatty acids and ketones, an alternate fuel source to glucose. Now, our bodies evolved to recognize fructose as a signal of upcoming scarcity and in turn store fat. But culture has now hijacked this evolutionary adaptation and rendered it maladaptive. Now, there is still considerable food scarcity in the world, and it is a prescient problem that must be addressed as we hurtle into increasing climate volatility. However, most of the Western world suffers from overnutrition and not undernutrition. Of course, the standard American diet is among the United States' most prominent exports, so this phenomenon is not just confined to the West. The overarching point here is billions of people can now, on a whim, in the palm of their hand or a short drive away, avail themselves of any kind of food in or out of season on a 365-day per year basis. Abundance is no longer balanced by scarcity. It's figs all day. Well, if only it were. In reality, it is sugary drinks sweetened with high fructose corn syrup all day and all night for many of us. 84% of the items in the average grocery store contain added sugar. generally refined sugar in some form of unpronounceable fructose-based compound. It's not just the Oreos and the Skittles. It's salad dressings and pasta sauces, processed meats and potato chips, breakfast cereals, and baked goods, many of which are engineered in a laboratory to hit your bliss point and trigger the neuropods in your gut to trick your brain into eating and wanting more. The body, in response, is simply doing what it has evolved to do: store fat. The fact that 45% of Americans are obese is a predictable consequence of the body's adaptive mechanisms being leveraged by culture. What was once adaptive is now maladaptive. But what happens when culture outpaces evolution? What happens when there is 365, 24/7 abundance regardless of seasonality? Now, by no means am I discounting the existence of famine, but there is little doubt that we live in a world in which the abundance of refined sugar and refined grain kill more people than food scarcity. And the overconsumption of these foods directly contributes to the epidemics of the 4 biggest chronic disease killers: heart disease, cancer, diabetes, and neurodegenerative diseases. The disappearance of scarcity due to modern industrial agriculture and globalization gives our bodies a singular message: grow. And this monotone dispatch comes at the expense of repair. The modern Western world sanctifies growth. Bigger is always better. That's the motto of Western culture. But you don't want your cancer to grow in your pancreas or fat to grow in and on your liver. You don't want beta amyloid proteins to accumulate in your brain, and you don't want advanced glycation end products to form in your bloodstream. In order to balance bulging biceps with cardiometabolic health, many people, including yours truly, are engineering scarcity in the form of intermittent fasting or time-restricted eating. We're living just a little bit more like Fedge. Now, fasting can take on many, many forms, from austere month-long water fast to weekly 24-hour fasts. Any fasting protocol should be discussed with your primary care physician, particularly if you're pregnant, menstruating, or nursing. Now, regardless of which specific protocol you adopt, fasting should be integrated slowly to allow your body to acclimate to a new feeding schedule. Now, most of the data that we have on fasting relates to the 16/8 time-restricted eating protocol, as researched by Sachin Panda's lab at the Salk Institute. Fasting protocols were utilized in the 1920s for the treatment of epilepsy in children. Now, for reasons that still aren't completely clear, fasting appears to be neuroprotective and inhibit seizures. Of course, adherence to fasting protocols among children is not particularly reliable. This led doctors to develop fasting mimicking diets, including the ketogenic diet, which in some ways mirrors the effects of fasting. Now, this treatment for epilepsy drifted out of vogue as anticonvulsant drugs were developed. Still, fasting is considered a very potent protocol for epilepsy, as at least 1/3 of people suffering from seizures are resistant to epilepsy medication. Now, 2 years ago, upon discovering that I was pre-diabetic, I began intermittent fasting, ironically but not purposefully, timed with Lent. Now, along with consolidating food consumption into 8-hour blocks, I also affixed a continuous glucose monitor, this one right here, to my triceps. I then studied my metabolism with a bookkeeper's zeal, and the results were amazing. In just 3 months, I brought down my fasting glucose levels from 125 to 90 milligrams per deciliter and began to reverse my insulin resistance. So here's my daily fasting regime, and no, I'm not neurotic about it. I try to consolidate all of my eating in an 8-hour window between 11 a.m. and 7 p.m. Now, I take advantage of sleep as a de facto 8-hour fast while also maintaining some small semblance of a social life. And it's become quite easy for me not to eat in the morning. Yes, you can drink coffee and you can drink tea and maintain a fasted state, provided you don't add milks or sugars. And indeed, I do slurp an espresso with a shot or two of MCT oil, medium chain triglycerides, about an hour after I wake up. I also drink plenty of lemon water. Lemons and limes are a very effective glucose disposal agent. The acetic acid in vinegar is also a really potent glucose sink, so you can put vinegar in water or just do a tablespoon straight. I also do consume a rather vulgar concoction of greens, replete with prebiotic fiber and phytonutrients and adaptogens, with a turmeric extract, which is anti-inflammatory. And I've estimated that to be around 30 calories, and I can burn that off in a few trips up and down my extensive outdoor staircase. So I combine intermittent fasting with a plant-focused ketogenic diet. I eat occasionally omega-3 rich oily fish. And I'll preserve a deep dive on diet for another time, but it's very related to blood glucose levels. Now, everyone is different, but I can categorically claim that the consumption of refined sugar, refined grains, and processed meats are going to lead to high blood glucose levels, to hyperglycemia, which is the precursor for type 2 diabetes and heart disease. Okay, so we're going to get just a little geeky and dive into some of the mechanisms of metabolism. Now, not everyone wants a science lesson, but I guarantee that the more you understand about the underlying functionality of your body, the more likely you are to actually adopt the protocols and tweak them and get the results that you're looking for. So here's just a brief primer on metabolism and blood glucose. So your body needs energy to function, right? So fortunately, we all have our own energy producing power plants in our cells called mitochondria. Now, every cell in our body, except our red blood cells, contain a different number of mitochondria that produce energy through a 3-part process called cellular respiration. Now, your neurons in your brain, your cardiac cells in and around your heart, brown fat, and muscle cells boast the highest concentrations of mitochondria. And this makes sense given their energy requirements of those cells. Now, your body generally uses glucose from carbohydrates to generate energy in the form of ATP, adenosine triphosphate. Glucose is absorbed through your small intestine as you digest food and into your bloodstream and ushered to your cells by a peptide hormone called insulin, which is secreted and made from your pancreas. Now, if you have too much serum glucose because you've just scarfed down 3 bowls of pasta, a donut, and a soda, your pancreas will need to produce more insulin to properly do its job. And if this pattern continues, then eventually your cells will become very stingy about letting glucose in, and you will become insulin resistant. Now, when high levels of glucose are abandoned in the bloodstream, a few things can happen, including some glucose can get stored in the liver as glycogen. Some glucose will get converted into triglycerides and stored in adipose tissue, fat. And some glucose may combine with hemoglobin, the protein in your blood famously tasked with shepherding oxygen to your cells, to form these super inflammatory glycoproteins, which is awful for your vascular system. High blood sugar levels are concomitant obviously with diabetes, which is correlated with cardiovascular disease and dementia. In fact, dementia is known these days as type 3 diabetes. In short, this is why sugar can be considered the world's most dangerous assassin. So fasting, among other things, lowers blood glucose levels and by extension, lowers insulin. Fasting also activates a number of different processes in the body and confers a wide range of benefits, some of which I will enumerate here. So number one, burning fat. Now, when you fast, as I explained, blood glucose levels plummet. Low glucose levels trigger insulin's yin counterpart, another peptide hormone called glucagon, who, given its non-celebrity status, could really benefit from a better PR person. Now, this hormone is so important. It's also secreted from the pancreas and prompts a few processes. Number one, the release of glycogen, stored glucose from the liver. Number two, a process called gluconeogenesis, which is the endogenous production of glucose in the liver. And number three, and most importantly for this conversation, lipolysis, the breakdown of triglycerides, of your fat, into free fatty acids and glycerol to produce energy. In other words, instead of your mitochondria burning glucose for energy, when you're fasting, it burns fat. And this process is also associated with ketosis, in which some free fatty acids become ketones that cells can leverage for energy production, particularly your brain cells. Now, ketones have the additional benefit of reducing the production of free radicals and reactive oxygen species during energy production. We'll touch on that later in the course. Now, the benefits of fasting go well beyond burning fat. Let's talk about weight loss for a minute. Now, one of the byproducts of fasting can be weight loss, though this obviously depends on the amount and quality of food you eat during the feeding window. Generally, one tends to consume less calories and the right calories when one is focusing close attention on behavior like a fasting protocol. Of course, you could eat 4 gallons of Rocky Road within an 8-hour feeding window, and this will not result in weight loss. Further, and this is interesting, you can eat the exact same diet and maintain weight in a 24-hour feeding cycle while losing weight in a time-restricted protocol. Now, if you want to go deeper on fasting and metabolism, I suggest reading the highly stringent studies conducted by Sachin Panda and his lab. Now, for the vain among us, weight loss can obviously help you look better, but losing weight in the form of visceral fat has more profound benefits. This oxidation of adipose tissue lessens the workload on the heart, and it reduces systemic inflammation. Okay, let's talk about cellular cleanup and recycling. Now, fasting is a signal that activates a cellular pathway in the body known as AMPK. In low energy states, AMPK opposes another pathway called mTOR. That's the pathway for cellular growth. This inhibition triggers a process known as autophagy, the body's system for cleaning out dysfunctional cells. Essentially, in the process of autophagy, damaged proteins are broken down into their amino acid building blocks such that they can be recycled by your cells for new protein synthesis. This housekeeping process is a crucial cellular process for longevity. Okay, back to the mitochondria for a second. Mitochondrial activity declines with age. We all kind of feel that as a product of direct experience. But AMPK activation also counteracts this decline by triggering mitochondrial biogenesis, the production of new healthy energy power plants. Now, having greater numbers of healthy mitochondria as we age may protect against all sorts of age-related declines, such as cognitive dysfunction. Okay, DNA expression. So every cell in your body contains DNA, the exact same DNA actually, which has a fixed nucleotide sequence that is unique to you. Your DNA expresses itself by giving protein recipes to RNA, which then ventures out of the cell nucleus and into the cytoplasm and delivers these transcriptions to your ribosomes that in turn produce proteins. Now, while your DNA is fixed, its expression is not. Your epigenome marks your DNA in a manner that influences the timing and the content of its recipes. And to use a musical analogy, your DNA are basically the piano keys. They never change. But your epigenome is the piano player. It plays a different song. Now, fasting activates sirtuins, a family of 7 proteins that regulate cellular function and DNA expression. Now, sirtuins are the virtuoso pianists in that they help maintain the proper genomic expression. They also upgrade mitochondrial function and suppress tumor growth. There is a famous Australian biologist named David Sinclair, and he famously demonstrated that depriving yeast of calories in a fasted, time-restricted eating protocol significantly extended their lifespan through improving DNA expression. Now, parenthetically, eating plants rich in polyphenols like resveratrol may also activate these sirtuins. And not surprisingly, the plants that are highest in these phytonutrients are the most stressed ones. We'll have a separate episode on stressed plants. Plants, like humans, can positively respond to low-grade stressors like drought and generate these self-protecting compounds. Grapes, used for the production of wine, are often purposefully stressed by vintners. Hence, wine, specifically the Pinot Noir grape, contains resveratrol, but not nearly enough to have significant impact. Now, we can supplement with resveratrol and NMN, the precursor to NAD, to stimulate sirtuin activity. And I'll cover this in greater depth in the Eat Stressed Plants session. Okay, one more great attribute of fasting is antioxidant production. Recent studies in mice, and we're not mice, but it is a good clue, have shown that fasting increased NRF2 binding. So NRF2 is a transcription factor that induces mRNA expression related to the production of antioxidants like glutathione. Now, glutathione is so important because it neutralizes free radicals that can lead to oxidative stress in the body, and this is also incredibly crucial to longevity. Lastly, the microbiome. Now, in your large intestine, there are 39 trillion bacteria that mediate a huge variety of physiological systems, from digestion to immunity to mood regulation. These bugs are separated from your bloodstream and most of your immune system by a microscopically thin epithelial wall. And the breakdown of the integrity of these tight junctions that make up this wall is called leaky gut, or more technically, intestinal permeability. Now, when your gut is leaky, endotoxins seep into your bloodstream, eliciting an inflammatory response. And if dysbiosis, the disruption of your gut bacteria, and permeability persist, you can end up with chronic inflammation. Your body can also begin attacking itself. These are known as autoimmune diseases like ulcerative colitis, IBS, and Crohn's disease. These are the most common due to poor gut health. So research into the impacts of fasting on the microbiome is still very preliminary and confined to a few in vivo mice studies. However, there is some early data that demonstrates that time-restricted feeding can lead to an increase in a bacteria known as Akkermansia. That's a particular strain, as well as an uptick in the production of butyrate, a short-chain fatty acid, which is a postbiotic, basically, produced by bacteria. And butyrate promotes epithelial integrity and upregulates insulin sensitivity. In short, Fasting improves metabolic function in so many ways and addresses many of the hallmarks of aging. So to close this session, let me return to where I started and talk just for a second about the spiritual and psychological components of fasting. Now, even though I don't subscribe to dualistic traditions that divide the body from the soul, there is a quality to fasting that is patently beyond physical. It is a spiritual pursuit. Now, when I started the 16-8 protocol, I had a craving not to crave. Of course, this is a paradox, but I didn't want to incessantly pine for external agents, things outside myself to satiate my perceived needs. About 2 weeks in, I stopped feeling unnecessarily hungry. I unwound the habit of mindlessly eating, and I developed the ability to delineate between hunger as a biological need and a psychological desire. And if one can stop craving food, then one can certainly stop instinctively grabbing for their phone or the wine bottle or the credit card in search of some ephemeral pleasure. Fasting as a practice is applicable well beyond food. As Buddha instructed, the cessation of craving is a stepping stone to nirvana, to liberation and contentment. Okay, I hope you enjoyed this session on fasting. In the next video, I will lay out the blueprint for a simple fasting protocol. Hey, thanks a lot for watching. If you enjoyed this video, then I think you'll love this one too.